So question 7.1, in the diagram below, the graph of f of x, which is equals to minus 2 sine x, is drawn for the interval from minus 180 to 180. Then 7.1 says, on the grid provided in the answer book, draw the graph of g of x, which is equals to cos x minus 60 for x in the interval minus 180 to 180. Clearly show all intercepts with the axis and turning points of the graph. So we have to draw the graph of cos x minus 60 for all values from minus 180 to 180 onto this plot. So in your answer book, you'll be given a similar plot with the graph of f of x already drawn into it. So in order for you to draw this graph, it is imperative that you know what a standard cos graph looks like. So standard cos graph would start from 1, then go down, and then end somewhere like that where it started. And on the other side, it would repeat the same thing, like that. So to identify the key points, this is 0, this is 90, this is 180, this is 270, and this is 360, where it makes its turn again. Then same thing for the negative side, negative 90, negative 180, negative 270, and then negative 360 somewhere there. So here we have to draw a graph of cos that is not standard. It is a graph of cos that has been shifted 60 units to the right, which means all the points that we know usually from where they start are now shifted 60 units to the right, like that. So if you can use your calculator to try and find these points such that you can plot a normal graph somewhere on a rough sketch on the side, or if you already have it in your head, all the better. Then what you're going to do is you would say cos of 0 is 1, but I know that that point 0 has been shifted 60 degrees to the right, so that will be over here. So by using your critical points, you can find where the turning points and the intercepts will be. Then you can just continue on that way. You know, at 90, that's when the graph would normally be crossing down, but now it will be shifted by 60 degrees. So it will cross down at that point over there. And then same thing for the negative side, minus 90, that will be shifted. There are 60 degrees. As you can see, the demarcations here represent 30 degrees. 30, 60, 90. So on the negative side, it will be the same thing. Usually we have a graph going like this. It usually goes down at 30, 60. It usually goes down at 90 like that. But now it will be going down at 30, 60, or 60 degrees from this side. So you can move 60 this point, move it 60 degrees to the right. That will be 30, 60. So somewhere over here as well, graph will go down. And again, it usually turns at minus 180, which means it's usually minus 1 here. But again, it will be shifted 60 degrees to the right, like that. And then you can just see how these points are separated. They're on every third line. So it kind of follows a pattern. At some point you'll be able to figure it out. But since we're ending it over here, we're bounded by these regions. We can't continue our plot anymore. So we know here is the 180 where it usually has the turning point, which would be something like that. Which will go up and then turn, and then go back down again, like that. And then you can just extrapolate these points so that they continue as you know, this is a continuous graph. It's just bounded by these points. That's why we limit it as we do, just like that. And that is your plot.